Hi, everyone, and welcome to the Constellation Crew program this Friday evening. Happy Friday the 13th, everyone. Tonight we have quite a few people from the Constellation Crew with us, but not Melanie. Melanie has the night off. Instead, we have Alec helping out in the chat. If you have any questions, go ahead and put them in the chat, and Alec will help you out there. I also can see the chat here, so I'll be able to answer some questions as well. But on the air here tonight, we have Ricky. Hi, Ricky. How's it going?
Hey.
And we have Nicolette. Hey, Nicolette. And we have Caleb. Hey, Caleb.
Hey.
And tonight we are exploring yet another constellation, one that you might be pretty familiar with, but you might not have ever been able to find in the sky because it's actually quite hard. And that is the constellation called Pisces, the fish. But before we get to Pisces, we're set up here in Muncie, Indiana, right before sunset in our simulation here. And this is showing the sky tonight a little bit ago. You can see the sun on the horizon where the sky meets the ground in the southwestern sky here. And we're looking at a part of campus. So we have the bell tower down there. You can just barely see it at the bottom of your screen. And we're facing south. That S does stand for south. And you can start to see a little bit in the sky this time of the evening, even before it gets completely dark. And we're seeing one object, one star-like object in the south right now. Does anyone here, Ricky, Nicolette, or Caleb, know what that is right here? It's a planet.
Yeah. I'm going to guess Mars.
Not Mars.
Venus, then?
We're going to be talking about Mars a lot this evening, but it's not Mars.
Jupiter?
And Venus is a little bit closer to the sun usually. Caleb, what did you say?
Jupiter?
It is Jupiter. Yep. So we have Jupiter in the southern sky. It's this really bright object in the south right after sunset. And as it gets later in the evening, you should be able to see it a little bit better in the south. And next to it is a fainter object, and that is planet Saturn, the one with the big rings. So we have Jupiter and Saturn in the south. And in the east, Ricky, is Mars, the red planet. And Mars does look red in our simulation here and red in the night sky. So Mars is opposite the sun in the sky. It rises in the east as the sun sets in the western sky. And Mars, we're talking about a lot because it's in the constellation we're looking at today. It's in the constellation of Pisces, the fish. Again, not too many bright stars in this constellation, really hard to find, but if you can find Mars tonight, then you're looking in the right direction for Pisces. And a lot of you have heard about Pisces because Pisces is one of the 12 constellations of the zodiac. We actually do explore the zodiac in astronomy classes because they're special. That's where you're going to find the planets in the sky. It's where you find the moon, more or less, in the sky. And it's also where you find the sun in the sky. That's actually what defines these constellations that we call the zodiac. And as we go into space here, we're going to take a trip to explore the red planet Mars. We can see that the constellations stay pretty much the same in the sky, even all the way in space, because these stars that make up those constellations are really, really far away. We don't see them change their patterns in the sky. So we can actually use the stars to help us navigate space, and then also help spacecraft navigate space as well. Because if you look down back at our planet, we have north, we have south that's down here out of view, we have east and west here. And they are sticking with the planet because there's no north, south, east, or west in space. You can't use a compass in space. Instead, spacecraft use the stars to navigate. And if we do that, if we use the stars to navigate and help us get to Mars, we're going to want to go in the direction of Pisces. So we have star trackers that are helping spacecraft right now, a spacecraft right now, getting to Mars, finding those stars to help it travel there. All right, so we zoomed in on Mars here, and we can see that there's some objects around Mars, right, Nicolette?
Yes, those are Mars's moons. they're actually pretty fascinating to me personally, because as we will zoom in on Phobos later in the program, you'll notice that Phobos is not completely round like our moon or spherical. They have interesting shapes, but they orbit around Mars. Phobos is the closest, as you can see here, and Deimos is the furthest. For those who are a little bit interested in mythology, Mars is the Roman god of war. The equivalent Greek god is Ares, also the god of war, and Ares actually has two children named Phobos and Deimos. So this is what Phobos looks like. Again, very interesting. It's
Yeah,
the largest of the two.
They're pretty small moons. They think that they're captured asteroids, actually, that got captured by Mars's gravity as asteroids got too close to the planet and became moons.
Yeah. It's very interesting. Honestly, I'm not totally sure. Crew, please correct me if I'm wrong, but we don't know the exact origin of our moon. There are multiple different kinds. I like to think of the one where either a planet or an asteroid hit Earth during its early evolutional stage, and some of the debris from Earth formed the moon.
Yeah, they're pretty sure that a collision formed the moon. It's more about they're trying to figure out more what that collision looked like. Was it a kind of a glancing blow? Was it a head-on collision? Or was it something so powerful that it kind of vaporized the young Earth and the object that hit the young Earth and created this whole cloud of material, this really hot, dense cloud that then formed again the Earth and then an object around it, our moon. And that's the synestia theory. So it's not, of course, just a whole cloud of gas and dust. It wasn't that powerful of a collision, but it was the Earth that survived the collision, and then a whole bunch of material around it that then recombined and got really mixed together to form the moon, which is why they think the moon looks so much like the Earth as far as the chemicals and elements that are there.
It's very fascinating. I love origin stories of the planets and the moons. But like you said, they do look like asteroids. So I do believe you're right. They're probably captured asteroids.
Yeah, like we weren't there. Like we don't know for sure, but
Right.
like, you can tell like, by what they look like and everything that they're probably captured asteroids. And this moon here, Phobos, is actually getting closer and closer to the planet. It's getting kind of pulled in by Mars's gravity. And eventually they think that it's going to get torn apart, scientists do, and become a ring system around planet Mars. So as it gets closer and closer, it feels more gravitational forces. There's tidal forces placed on it by Mars that can rip it apart, and maybe it'll become that ring system. But that won't happen for like 25 million years, so we're not going to be around to see.
Yeah, sadly. Thought that would be really cool.
All right, so up close Mars, the red planet, kind of looks more like butterscotch color, kind of tan. But it's got this huge feature on it. What's that all about, Nicolette?
So, again, correct me if I'm wrong. I'm not very good at pronouncing things, but this is called the Valles Marineris. Am I correct? Okay. So this is basically a giant canyon, kind of like the Grand Canyon, but way bigger, way bigger. A lot of people, or it has been known to be 2,500 miles long and 6 miles deep-ish, roughly. Surprisingly, in the simulation, you could see it kind of far away from Mars. Before we got too deep into it, you can actually see this canyon with a telescope on Earth on a clear night. Of course, all the situations have to be right, and you have to have a really good telescope, but you won't see it in great detail. It'll just appear as like a big scar, a dark scar on Mars, or a smudge, if you will.
Yeah. It's huge. I think our Grand Canyon is just as big as one of the little tributaries off of the Valles Marineris there.
Yes. It has been, I think it's also as large as the continental US if you were to take it and place it on Earth.
Hmm. Yeah, and Mars is only half the size of Earth, so it's definitely very, very large for it being such a small planet.
Yes,
It's
very
the second smallest. Second smallest? It's larger than Mercury, but not as large as Earth and Venus, of the terrestrial planets in our solar system. But it's got a lot of great geology on the surface. It's really fascinating. The history of Mars intrigues many. We know a lot about Mars because we've sent rovers and spacecraft there, and we're going to talk about those in a little bit. But what are these things? Because this is not a crater here, right, Nicolette?
Right, that is not a crater. That is actually an opening for a volcano. So you'll see other ones as well. If you look further down, there are some other volcanoes as well. But the biggest one that we're looking at right now is called Olympus. And it is the largest volcano in the entire solar system. As we get closer, you'll start to notice that it's not active. You can't see in the crater any lava coming out of it or going deep in it. So it is an inactive volcano on Mars, but it is huge. It is 26 kilometers, or for those who like miles, 15 miles tall, and 500 kilometers or 300 miles wide in length. It is massive.
Yeah. Dam alone, I'm going to pause it here because we're going to go back in time and see Mars 4 billion years ago. But just to make a quick comment on one of the comments in the chat, Dan Malone said that you can actually see 5 planets in our night sky. We mentioned Jupiter, Saturn, and Mars, but on either side of Mars are 2 planets that you can't see with your eyes. You can actually get a look at them with a telescope, a good telescope. You can see Uranus to the east of Mars in the sky, and then Neptune to the west of it. And we'll point out those kind of locations in a little bit. But let's go back in time and see what Mars's surface may have looked like about 4 billion years ago. We think our solar system, our Earth, formed about that time, 4.5 billion years ago. And as you can see, there's like clouds in the sky. It almost looks like Earth here. This is Mars, though. So they have really good evidence that there was flowing water on Mars, and that Mars, in order to have that water on the surface, had more stable temperatures, warmer temperatures, thriving atmosphere, and weather as well. But at some point, less than 1 billion years after Mars was formed, it's lost its magnetic field, and we'll learn more about that later. But because it lost that, it lost its protection from these particles from the sun that changed the planet. And again, we'll learn more about that a little bit later. So the planet became what we see today. And so we know a lot about Mars because we've sent rovers there. Like I mentioned, we also sent spacecraft there. There are multiple spacecraft going around the planet, taking pictures and gathering data. We're going to look at this one a little bit later on that just flew by. That was the Maven spacecraft. But let's look at Mars today. And Mars today has this rover on it. What's this rover all about, Caleb?
Yes, this is a rover that's known as the Curiosity rover. This was sent to Mars. This launched from Earth in 2011 and then reached Mars in 2012. So it's been gathering a lot of data for the last 8 years about the planet. Actually, it's found some pretty good it's evidence for possible life on Mars due to the planet's past. One of the things it's found is that there's evidence that there was liquid water on Mars. It's found pebbles that are rounded that good evidence to say that there were rivers on Mars that formed these rounded pebbles. And it's also found that Mars had a thicker atmosphere back in the past. Evidence for that. So
yeah, so it's found evidence that life may have been able to survive on this planet at some point. Not necessarily sure if there's evidence of life there today. It doesn't have the capability to look at, its samples at that level of detail. There is another rover, though, on its way to the red planet. This one, like Caleb said, has been roving around the planet for 8 years now, and it's got some wear on its tires. The tires do have holes in it naturally, but you can see in the kind of the middle one on the right here that there's some extra holes and there's damage. They're getting damaged more than scientists would like, but it's holding up pretty nicely for 8 years. Just got a little dust on it. In the back, you can see what powers it. It's kind of this thing that has these fans on it. Let me see if I can show my cursor eventually, but that's the RTG in the back there. So it uses nuclear power to get all of its energy and rove around the surface. It doesn't use solar power or any solar panels to gather that power to work, which I always thought was pretty interesting. All right, so the next rover, Mars 2020, is on its way. This is it being worked on before they sent it off to go and travel to Mars here. And what's this called, Caleb?
This is known as the Perseverance rover. It was sent earlier this year, I think back in July, and it's expected to arrive on Mars in about February. So about a roughly 7 month journey to the red planet. So
yeah, it takes about seven months. It used to take about 9 months. I don't know if technology improved, but they got the trip down to 7 months to get a rover there, which is pretty cool. Humans? I don't know. I don't know if it would take a little bit longer for humans to get there, because humans are a little bit more fragile than the rovers.
A little bit.
For some reason, my brain wasn't clicking, and I was like, wait, doesn't it take days to get to the moon? Yes, because it's closer. Months are longer than days.
Months are longer than days. I don't know if you know, Nicolette, but it's kind of been an interesting year. And months are, turning into days, and days are turning into months, and everyone's time is all messed up. So
yeah.
We have to remind each other what exactly time means.
Yes, honestly. Yeah. Oh my goodness.
I think what's interesting about this, about sending these rovers to Mars, that they can't just launch, them to where Mars currently is and think that and have it be there. They have to carefully calculate the routes that these rovers will take to get there.
Right. Because otherwise it'll miss. Pew.
Yeah.
Mm-hmm. Yeah, for sure. All right, so where is Perseverance, or Percy, as it's being fondly called? Percy earlier today, well, you can see the numbers here, but it's about a little over halfway there. 58.3% of its trip is completed. So it's going at 58,000 miles per hour.
Yeah. Doesn't sound like a safe journey.
Like if we went that fast, how do you think we would handle it? Humans. Huh?
No.
Well, it's not the speed that kills you, it's that stop. It's the sudden stop.
It's the stop. It's the acceleration. Yeah. So there's speed, and then there's speed or velocity, which they're not the same, but there's speed, and then there's you can also hear it be referred to as velocity when you have direction involved. But then there's also acceleration, and it's the acceleration that we would want to worry about. You know how Star Trek got around the sudden accelerations to like light speed?
Yeah.
They were warping. They weren't the ones moving. right?
Either way, that's just no. I live in
They're still
Illinois
moving.
from Six Flags. So the fastest roller coaster there is 85 miles an hour, and I can't handle that. My brain hurts. And
Yeah,
that's not even close to how fast that
You
is.
think-
right. So like
you
you
think
would
about
have
it,
to
this-
slowly get up to that speed so that you could handle the acceleration. But like once you're at that speed, like and you're staying there, like you're just hanging out, right? You don't really feel it because we're on Earth. We're going really fast on spaceship Earth here right now, but we're moving along with it, so we don't really notice it. And we're traveling at a
You think about
constant
it.
speed.
Makes more
You
sense.
think about it, this with as fast as this thing is going, this thing is going about like several miles in a single second. I mean,
Yeah.
when you think about it, it would take you like going at the speed limit on a highway, it would take you 8 minutes to get that far. Get 8 minutes to get that far, and whereas it would take that distance would take around 1 second.
So Star Trek had inertial dampeners to make it so that things didn't get bounced around. That was like the first thing that went offline when they got into like a battle, so that it would be more interesting on screen to like see them like move around and have things get knocked off tables and stuff. So
Wow, that's cool.
But just
I really don't know much about Star Trek. I've always been a Star Wars fan.
Same.
You're a Star Trek fan.
Really cool. Makes me want to watch that.
all right, what did you say, Ricky? I can't hear you. I'm sorry.
Oh, I just outed myself as a non-Star Trek fan.
Got it.
Never seen it.
We're going to change the subject now because there's a really cool thing here. So this is something else that was being created in the lab with Percy. And let's see a video of it because it's kind of hard to tell what exactly this is, but it's got some blades because it's a helicopter. It's Ingenuity, the first helicopter going to Mars. All right, so got some people working on it. It takes a lot of people to do these missions. It's not the technology that does science, it's the people. So what's going on with Ingenuity, Caleb?
Ingenuity. I mean, we should also mention that Ingenuity is actually traveling along with Perseverance. So when Perseverance lands, Ingenuity will also be deployed. So Ingenuity is like basically a technological test. It's basically the test. Like helicopter
From the surface and just doing some tests just to see what if it can do it and to pave the way for the future generations. I think we went offline.
Uh-oh.
Oh,
No, I think we're still going, so maybe.
good.
I think we're back. All right, so let's just keep on going here. So we have heard from Ricky on this little guy here. Their blades are going in different directions, Ricky. What's the reason for that?
So that'll be, so if they were both going the same direction, they would give it some angular momentum, and it would like do pirouettes in the sky. So if you have them go the opposite directions, they'll cancel each other out. It's for the same reason that like regular helicopters have that tail blade to kind of cancel that out and stop it from spinning left or right.
The little one.
It could actually just stay there.
So it stabilizes it. That's really
And
interesting.
it's got the added benefit of giving you more thrust too.
Cool. All right, so we talked about Mars's thin atmosphere, and we know that it, probably had a thicker atmosphere at one point. So what happened to it? Well, this is a simulation showing solar wind. So we know that there's this thing called solar wind. It's streams of charged particles coming from our sun, electrons and protons, mostly protons here. But that interacts with our planets in our solar system. It kind of hits the planets and gets deflected by them, or it can run into the magnetic field of planets if the planet has a magnetic field, like our Earth has a magnetic field. And crew, what happens to these charged particles when they interact with our magnetic field of Earth, especially at the North and South Pole.
Oh, they make a light show.
They make a light show, yeah. They make the northern lights and the southern lights, the aurora borealis and the aurora australis. And other planets, though, they can get aurorae too. But Mars, not so much, because the solar wind is interacting with the planet itself. It doesn't have a magnetic field. We think it once did, but not anymore. So what is the solar wind doing to the planet since it's interacting with it so powerfully? So let's see. You can see it kind of getting deflected here a little bit by the planet. But it's going to show you these colored lines here. It says that it's escaping ions in this simulation. Well, what does that actually mean? Well, there's particles in Mars's atmosphere. Mars does have an atmosphere, like Caleb said. It's 100 times thinner than our own. And it's getting stripped away. You can see that the particles in the atmosphere that, again, are being represented by these colors, these colored lines, are moving away from the planet, getting stripped away by the solar wind. It loses quite a bit of its atmosphere. It loses, a quarter of a pound, I think, every minute. Let's see. Loses a quarter of a pound every second, actually. So it's losing its atmosphere very, very quickly. So the charged particles from the sun hit the atmosphere, and it gets so much energy that it can escape from the gravity of Mars and go off into space. And we know that because of the MAVEN spacecraft that's going around the planet, taking data of all of this, providing us simulations like what we just saw. So what happened to Mars's magnetosphere? Well, that's what InSight is going to try to find out, because magnetospheres, magnetic fields, are generated deep inside planets. And so we think that Mars, because it's half the size of our planet, it's smaller, it's farther away from the sun, it cooled off really quickly, it doesn't really have an active interior anymore. And therefore, there's no active interior to drive a magnetic field and protect its atmosphere from the solar wind. So this lander here landed about 2 years ago. This is called InSight, and it has this guy here. Anyone know what that is, crew? Or anyone watching?
I don't know.
That is a seismometer. And in astronomy, we don't really hear about that too much. But it's trying to figure out things about Mars quakes. How we have earthquakes here on Earth. Well, there's some Mars quakes. It's only detected a small one so far. It's also looking at the rotation and interior of the planet. So Mars does spin on an axis and that wobbles over time. It's looking at that. And this is all to help us understand its interior better. So InSight is really the first lander, first spacecraft to Mars that's really looking at the interior of the planet directly with the seismometer that you're seeing here. And then there's one more thing, a heat probe that's going to kind of drill or get put into the surface of Mars and take its temperature, basically. Try to figure out how warm or cold it is inside the planet itself, which is pretty cool. So what would cause a Mars quake, by the way, crew? What do you think?
I don't know if its core is gone.
Like, does Mars, like, what causes earthquakes here?
Well,
Mantle.
it usually the shift in the mantle, yeah, of the what do you call them?
The plates?
Tectonic plates.
Tectonic
Yeah,
plates, yeah.
tectonic plates.
Yeah, so does Mars have tectonic plates, do you think?
It depends on how active
It has
the
to, if it
mantle
was
is.
volcanically active, right?
Well, that's the question. That's a good question.
Like, does
So,
it still have
what
them, though?
about like Hawaii? You know, the volcanoes in Hawaii?
Mm-hmm.
Well, Hawaii
Are
sits
the-
on top of as a hotspot, you know, in
Yep.
the Pacific Plate. So
Yeah, so there's hot spots, and that's not a plate boundary that would drive volcanic activity. So the shield volcanoes on Mars are from hot spots. Scientists think that's what they believe. There's no evidence of tectonic plates on Mars yet. But that's what InSight is trying to find out. It's trying to find out more about the interior and see how warm it is and what's going on underneath, how thick its mantle is, and all of that.
Well, that's interesting. In
Yeah.
elementary school and high school, they would always say, "Oh, Mars is a dead planet. The core is dead," and they would never speculate on that. But now, getting to Ball State, people are specifying that we don't know. We assume it's cold and not as active as Earth's, but they don't say, "Oh, it's dead."
Yeah, it's more of like, yeah, it's we don't know, but we're pretty sure it's inactive. It doesn't have any. There have been some publications, I think one that it comes to my mind anyway, about it having about there being evidence that it is active. It does have plate tectonics, but I think most evidence is pointing in the other direction. But again, that's why InSight is there, is trying to find out more. And it has been really quiet. Like that seismometer has only detected one possible Mars quake since it landed 2 years ago. But it takes time for the equipment to get set up. It had to take it from the top of the lander and put it safely on the planet, make sure it gets settled down, and get calibrated and all of that. So maybe we'll find more soon. What would cause a Mars quake then if it doesn't have plate tectonics?
Little people.
Well,
The
it
green.
has moons, so it's got to have some tidal activity that could cause a
Those moons are pretty
minor
small,
quake.
though.
They're small, but give me a break here. Like,
Well, yours sounded way better than me with the green men and the little people.
with the what?
honestly, I'm not sure. I mean,
Well, if it has any type of core going on, like that could cause some stuff. Just the fact that it's a planet, it's big, like it can't be completely settled even now.
Think about think about the moon. The moon has moonquakes.
Hmm.
What's going on the moon that would cause that? Because the moon doesn't have plate tectonics either. It doesn't have a core that's generating heat that we know about anyway. What about like just temperature changes, right?
Yeah, like the moon goes really hot and cold. That could.
usually the magma in the Earth's changes because like it cooler parts are settling and hotter parts are rising. So
Yeah.
maybe that could be what's happening with Mars and the Moon. So
Does Mars have large temperature changes when its day and night cycle?
It has temperature changes throughout its seasons. Day and night, it is going to be a larger variation than what we have here on Earth because, again, its atmosphere is thinner, so it can't trap in heat like our atmosphere can, or not as well anyway.
Yeah.
So it does go through pretty dramatic temperature changes. Not like the moon, though, because the moon's 2 weeks of nighttime, 2 weeks of daytime, and temperature changes 500 degrees or so.
Yeah, like that's more than enough to cause a moonquake.
Yeah, but yeah, they might be thermally generated on Mars, like they are on the moon, and also it detects like meteorite impacts, which can cause a little bit of activity on the planet. So, all right, so we ended up back on Earth. We're looking at the eastern sky after sunset. And this is here in Muncie or really anywhere in the US. You should be able to see this red object in the east, and that is planet Mars. And it's in the constellation of Pisces, the fish. Again, can't really find any or see any stars of that constellation with light pollution here in Muncie anyway. And the sun hasn't set all the way in our simulation here, so we really just see Mars. Pisces is hard to find in the sky, so we have Mars to help us tonight. Are there other planets in Pisces, crew?
Oh, well, didn't a comment say that there were other ones beside a planet, but they're faint to see. You can't see them with your eye.
Yeah, there was a comment
Yeah.
from Dan who said that there are 5 planets visible, 5, with a telescope. So if you have a backyard telescope that can see the planets pretty well, pretty decent one, you should be able to see 5 planets in your sky tonight. So there's Jupiter, Saturn, and Mars. Off to the east of Mars, kind of over here, is Uranus.
That was my guess.
And then to the right or to the west is Neptune. But those are in different constellations.
Yeah.
They're not technically in the constellation of Pisces, which is just kind of this block of the sky here, this puzzle piece here. So are there other planets in Pisces?
That's a no.
So yes, you knew that.
It wouldn't be Venus and Jupiter, no.
No, there's planets. They're not in our solar system though, right?
Oh,
They're
Okay.
outside of our solar system.
that's a trick question.
Going around other stars. It's
It was a
not a
trick
trick question. I didn't ask it in like a tricky way. I'm not trying to be sneaky here.
Well, he said it was broad, so it was just on us for not thinking outside the box.
Well, exoplanets are a completely different word.
Okay.
Yeah,
But they're still
I mean, you
planets.
should've
They're
said-
extrasolar planets.
Yeah.
Exoplanet is short for extrasolar planet. It's on the outline, Ricky. So there are exoplanets, so planets going around other stars outside of our solar system in the constellation of Pisces. We know about 13 stars in this constellation that have planets for sure, which is pretty exciting. But there's more than just planets in this constellation. There are also galaxies. So all of the stuff that we just spoke about is in our own Milky Way galaxy. But what about stars that are in groups outside of our Milky Way, like this one, M74? Ricky?
Mm-hmm. Well, yeah, this is M74. It's 30 million light years away. It's a spiral galaxy that's kind of facing straight on towards us. So it's really easy to see all the spiral arms, which makes it a really nice one to study. Another fun fact about it, though, is it's still a Messier object. So it's on the list of objects that Messier didn't like. He only cared about comets.
All right, so we have it in visible light, not invisible light here. And then let's shift to a different type of light, a light that our eyes cannot see directly. So we have to use technology to capture this information, and then we can color code it so that our eyes can really try to understand what's going on here. So this is the galaxy in infrared light. So infrared light shows us other things. It shows us hot ionized gas, and then also stars a little bit more clearly.
Yeah, it gives us a really good view of the spiral arms, because that's where a lot of that gas is going to be located.
Yeah. Now there's another galaxy that's a spiral galaxy, but it's, I think, a little bit more interesting because its spiral arms are really, really wound. They're wound really tight.
Yeah, it's a lot more tightly packed. It's still face on with us, so we get a good view of it, though.
It looks a little tilted, like alpha.
A little bit,
yeah.
But it's still enough we can clearly see what type of galaxy it is.
Mm-hmm. But do you think it's oval shaped?
It is a little oval shaped.
Do you think that's natural, or do you think that's because it's off our field of view?
I have to think about that. I think that's. I don't know. It could be because it's off. It could just be like that. It could just be like it do.
Question: Could it?
I think it's more likely that it's from being a little angled, though.
Yeah.
Question: Could it be that it's so wildly town that because it's spinning so fast, possibly, or could it be spinning fast enough that it would cause it to become more compacted due to the?
I don't know. Do you know how big this one is, Ricky? Because sometimes
how
more
big
massive,
in
mass
arc seconds? No, I don't know off the top of my head.
Size, yeah. I wonder how old it is too, because sometimes maybe the age might affect that as well.
I was thinking
Yeah.
that the black hole in the center is giant, and gravity is what's keeping it.
Oh,
So
we should probably say its name though. This is NGC 488.
Yeah. Or what is
It's
it
100
also known
million light
as?
years away. What?
I thought it also had like a, is this the Phantom one? There's a Phantom Galaxy. Remember?
Oh.
I didn't know if it was the
Yeah, I
previous
think
one.
that was this one.
This one was the Phantom Galaxy.
I think it might have been that last one. I don't remember.
the first one would make a little bit more sense because
I
this
think
one
it was
so
the
It was the
Messiah
first
74.
one. Yeah, the other one was
Yeah.
Phantom. This one is
That
just
one looks a
NGC
little-
488. I feel like this one should have the more clever name. I don't know. I just like this one better.
It should,
But-
it should have a clever name.
Yeah, I think this one should be better. I'll have the clever one. All right. Well, the next galaxy, or really set of galaxies, is our favorite out of the three. And these are all in the constellation of Pisces. But this one's really interesting because, well, Ricky, go ahead.
Yeah, well, this one's NGC 520. It's 105 million light years away, but it's really interesting because it's two galaxies that have collided. So this might be something like what our galaxy looks like when Andromeda collides with us. But it might be a little hard to see, but you should be able to see two distinct, I guess, blue lines at different angles. And that's both of the galaxies crashing through each other.
Yeah, it looks like there's a kind of an angle line here and another one here.
Yeah.
So two galaxies combining to form one.
It's really cool. And we've done simulations, and we think that they started colliding about 300 million years ago. That'll kind of get us a galaxy that looks like this. I think they're still on their first pass, which just goes to show how big they are.
So, like, you mean first pass, as in they're
Yeah, like
just,
the first collision before they
collide
started.
before they
So
go
I
back
think
out and then
so.
collide again.
Mhm.
But I might be way off base on that.
No, I'm just trying to understand what you meant by first pass. That
Yeah.
sounds cool.
But that's just what it looks most like.
Yeah.
All that and this part of the sky that really you can just see a red dot, which is Mars.
Yeah.
Pretty cool for our eyes, anyway. Like, so
Mhm.
it's amazing. There's so much more out there. All right, so we usually end our programs talking a little bit about the mythology of our constellations. Nicolette is our kind of expert there. I'll let her take it away.
Yes. So in past shows, there have been so many fantastic tales. We've had heroes rescue women. We've had just amazing goddesses. We've had so many stories. And this constellation is amazing with all of its detail and galaxies and exoplanets. But its mythology is not as exciting. It has a story. It's just not as like the romance and the heroes and the fighting giant monsters, So the Roman myth has to do with Venus and Cupid trying to escape a fire monster. So they tie themselves together with rope and escape in a river. And some versions of the Roman tale say they turn into fish once they get into the river and they swim away from the monster. Some say that they stay that way and then they're depicted as fish for some reason. And as we know, there are other cultures and other stories, so there could be other reasons why they are fish. There's also a little bit of Babylonian history going on here, but if you would like to know more, you'll have to do some of that on your own. But for Roman myth, it is basically just two gods and goddesses trying to escape a monster. And they may or may not turn into fish.
And they're tied together because why not?
Yes, they're tied together. And that is why, there's a cute little bow in that picture. I like it.
Yeah, I like our constellations that come with our planetarium system. They're drawn really nicely.
These fish aren't as scary. The viewers
Yeah.
that saw those fish. These fish look really nice. The
Yes.
others look scary.
Yeah, I prefer these ones. All right, so again, in the east, after sunset, you should be able to see a red star-looking object. It's no star. It is planet Mars. We also have Jupiter, which is really bright in the southern sky, and off to the left of it, there's planet Saturn. again after sunset. But Dan Malone mentioned in the chat that there are also 2 other planets on either side of Mars. Uranus is off to the left, Neptune is off to the right or to the west of the constellation, but you need a telescope to help you see those. And he also said recently that there are 2 more planets in the morning sky. So before sunrise, there's Venus, which is pretty bright. You don't usually need to have any optical aid to help you find Venus. It looks like the brightest object in the sky, unless the moon's up, really, and the sun, of course. But we have Venus, and then there's also Mercury visible. So he said that's 7 planets visible in the sky if you have the right tools to help you see it. And then, crew, how do you see the 8th planet in our solar system? You look down at your feet to see the Earth that we're on right now.
I can totally see it. Yeah.
All right.
I can see the Earth.
Or there's like the floor, and then beneath that is the Earth, or look outside. Whatever you need to do.
And you go down 3 flights of stairs, but yes.
Yeah. And that did come from Dan. So thank you, Dan, for your comments as usual. And thanks everyone so much for watching. Crew, do you have any final thoughts before we sign off tonight?
No.
All right. This is the last constellation crew that we're doing this year that focuses on a single constellation. Next week, we're going to explore our favorites from the series, the semester here at Ball State University. So we're going to be looking at a lot of different constellations and aspects of them that we've been exploring all semester long, and maybe do some trivia as well. So check us out next week, and that'll be the last constellation crew for the year, actually. So hope to see you next week, everyone. Have a great evening and a wonderful, peaceful weekend.